All right, so now we go up to an energy level of 2. So our possible L values are 0 to n minus 1. Okay, so 0 to 1. And with the 0, 1, again, our m sub L can only be 0, which means that it is a 2s orbital. And then our L value of 1 can have an m sub L of negative L to positive L. So negative 1, 0, 1. So that is a 2p orbital, and there are 3 different possible orbitals or orientations there. Then you go up to the third energy level, you add in your d orbital, which again has 5 different orientations, and then you add in the fourth energy level and you add in an f, okay, with its 7 different orientations. All right. So an occupied, now we're going to get into orbital notation. Okay, so an occupied orbital is represented by a line with the orbital's name written underneath it. So it will look something like this, okay, or an unoccupied orbital, okay. Now, if you're writing out an S, you only have one line above it. Any energy level S orbital will just have the one line above it. If you're writing out a P orbital, okay, you have the 3 lines. D orbitals, you would have the 5 lines, and for an F orbital, you would have the 7. Okay, just like that. All right, and then you also do have to have the energy level of that orbital written with it. Now, an orbital containing 1 electron is represented with an up arrow. Okay, so it would be like that. Okay. Moving along, an orbital containing 2 electrons would have both an up and a down arrow. So this is referring to the 2 different spins on an electron. So you have one going in the positive direction and one going in the negative direction. Okay? So you're not going to have one orbital with 2 up arrows. Okay? That won't happen. It's always one up, one down. And then the lines are labeled with the principal quantum number, so the energy level, and then the sub-level letter, the one that refers to the orbital shape, the orbital type. So, for instance, if you were going to do helium, helium only has those 2 electrons, and they both go into the 1s orbital. So you have your 1s, you draw a line, an arrow up, and draw an arrow down. Okay? So that is representing the 2 electrons in the helium atom. Now, for example, if we were going to do oxygen, the orbital notation for oxygen. Oxygen has 8 electrons, okay? And they go into the 1s, which can hold 2, the 2s, which holds 2 more, so we've got a total of 4, and then also the 2p, which can hold a total of 6, but we don't need all 6. Okay. Now the electrons, again, will go into the lowest energy level available, which means that you're going to fill up 1s first. Okay, so you have 1 electron pointing up and 1 pointing down. So you've taken care of 2 of your electrons and now you're down to 6. Okay, so now we do the same thing with the 2s because 2s is lower energy than the p. So now we've taken care of 2 more. So we only have 4 left. Okay, now electrons like their space, right? So when you're drawing the electrons into the 2p orbital, what you do is, since there are 3 areas available, you draw an up arrow into each of them. Now that's taking care of 3 more of our electrons, so we only have 1 left. And that is when you go back in and add in a down arrow. Okay? So in this way, you have the lowest energy levels filled first, and then when they go into the 2p orbitals, you have 2 electrons that have as much space as they want, and then in these 2 orbitals here, and then you have this one that is sharing that orbital. Okay, but they're still pretty happy because they're both going in opposite spins, and they do have enough room to move around. They just don't have all of the room to themselves. Okay, so let's do another example with that, let's do phosphorus. Okay, so phosphorus has a total of 15 electrons. Okay, so you have your 1s, you have a 2s, 2p, then you have 3s, and 3p. Alright, so we put 2 electrons in the first one here. Okay, so now we're down to 13. Put 2 more in the 2s there. Now we're down to 11. We're going to put 6 in 2p. Okay, so now we're down to 5. Now 2 more will go into the 3s. We're down to 3. And again, you only do up arrows going across. And then if we had any more electrons, we'd go back in and add them as down arrows. But we have used up all of our electrons. So this is the orbital notation for phosphorus. Okay? And again, you just go straight across. Basically, if you list them in the order of increasing energy, okay, then you can go in and fill in as they go along. Okay, so like your lowest energy level is on the left, so you fill that up first. Next lowest is the next one, so you fill that up second, so on and so forth. Okay, now it's important to note that these p orbitals have the same energy. Okay, so the 3p orbitals, all 3 of them have the same energy, which is why you will get 1 electron in each of the orbitals before you get a second one. Okay, because they have the same energy level, so that is not driving it into one of the orbitals over another one of the 3p orbitals over another 3p. Okay, so, alright, that is orbital notation and quantum numbers. So that is the end of this video.